Hello viewers, High Maths Academy coming with series of MCQs on CBSE Class 10 Maths covering all important topics. So don't go away, stay tuned to the channel.
Our session with a nice quotation. If you can dream it, you can do it. So if you want to achieve something, first we should have to dream about it. Then we should have to plan according to it. And then we should have to implement it. And by successful hard work, it will come true. So in this session, we are starting with MCQs on real numbers. See, MCQs are very crucial part in every examination, and easily we can score and we can save time also. If you practice in a proper manner, we can save most of the time. So before starting our class, just please subscribe my channel, like my video, and click on the bell symbol and select all. Like, comment, and share my video if you like this. Okay, let's start. See, the first MCQ is the decimal expansion of the number 14,753 upon 1,250 will terminate after options given 1 decimal place, 2 decimal places, 3 decimal places, and 4 decimal places. To say this, first we should have to look after the prime factorization of the denominator part. We should have to look after the prime factorization of the denominator 1250. Let us see how can we prime factorize this. So 5 table you can take 2 times 5 times 250 times. Again 5 table 50 times. Again 5 table 10 times. Again 5 table 2 times. So we have 4 5s and 1 2. So this can be written as 5 power 4 into 2 power 1. So before this, how many decimal places to find? We should have to know one point that if a rational number expressing in a decimal expansion, the denominator should be in the forms of 2 power m into 5 power n. So the prime factorization of the denominator should be 2 power m and 5 power n. Means it is the multiples of 2's or 5's, or only 2's, or only 5's, but not any other. If there is 2 power 3 into 5 power 4 into 3, 1 3 extra is there. So it can't express in the decimal form, terminating decimal. It is non-terminating, non-recurring decimal. So to express a rational number in a terminating decimal, the denominator should be expressed as powers of 2's and 5's. So in the given rational number 1250, it has 5 power 4 and 2 power 1. So it has only 5's and 2's. Okay, fine. It can be expressed as a terminating decimal. But our question is how many decimal places will be there in that decimal expansion. So the maximum power what is there, that many decimal places will be there. So here the maximum power is 4 and 2 is having 1. So we will consider 4. So therefore our option D, 4 decimal places in this decimal expansion of this rational number 14,753 upon 1,215 consists of 4 decimal places in its decimal expansion. Okay, and the key point is here the rational number whose denominator can be expressed as the multiples of 2's and 5's only terminates, and the rest does not terminate. It will maybe recurring or non-recurring. Okay, come on to the second one. The decimal expansion of the rational number 37 upon 2 square into 5 will terminate after C. Just now we discussed this. It belongs to the previous sum. Yeah, here the denominator is of multiples of 2s and 5. Yes, fine. It is terminating. Yes, we can say that. And we need to say how many decimal places. Here the maximum power is here 1 and 2. The power of 5 is 1 and the power of 2 is 2. So the maximum power is 2. So it can terminate after 2 decimal places. So option 2 is our correct answer. Option 2 is the correct answer. I hope you understand this. Let's move on to the next. See, the LCM of 2 cube and 3 square and 2 square and 3 power 3. See, before doing this sum, I will give small clue. If a power m, oh, not this. LCM means what? The maximum repetition, I think so. Am I right? See, whenever we observe the exponents in the two numbers, the LCM can be considered as the maximum power. So here, what are the prime numbers we are having? In this, we are having the prime numbers of 2, 3. Here also 2, 3. The same numbers will come in this LCM. And what about the powers? That is very important here. The maximum power we will consider as a LCM. If you want to find HCF, we will consider the least power. So here the two powers are 3 and 2. The maximum is 3. So we will take 3. And for 3, one is square and other one is cube. The maximum is 3. So we will take 3. LCM is 2 cube into 3 cube. Oh, this is our answer. If we want to find HCF, just if you want to find HCF here, how can we find HCF? See, HCF can be taken by taking the common number. See, 2 is repeating here and also here. So we will take 2. And 3 also repeating in both multiples. So 3. And coming to HCF, quite opposite to LCM. LCM we will take maximum power. In HCF we will take least power. 2 cube and 2 square. What is the least? 2 square. And 3 square and 3 cube. What is the least? 3 square. Coming to HCF, we should consider the least power. Coming to LCM, we should consider the highest power. You can understand? Okay, fine. Let's go question number 4. Given that HCF is 2520 and 6600 is 40 and LCM is 252 into K, then the value of K is, how can we find? Is any clue? Yes. Here, before doing this, we should have to know for one small thing. Product of LCM and HCF of two numbers is equal to product of that two numbers. So here, by this, we can say that, so LCM is 252 into K and HCF is 40 is equal to 2520 into 6600. So K is equal to 2520 into 6600 upon 252 into 40. Let us simplify this. So this is 10 times. The 0 gets cancelled. So I left with 6600 upon 4. So 16 times it is 64 and 20 it is 5 times. So 1650 is the required number K. So our answer is 1650. Do you understand? Product of LCM and HCF of two numbers is equal to product of that two numbers. So here LCM is given 252 into K and HCF is 40. That is equal to the two numbers product 2520 into 6600. Since 252 and 40 are multiplying, if you send that side, it get divide. So 252 into 2550, so 2520, 10 times. 0 cancel, 10 table 40, 4 times. So I left with 6600 by 4. It is 1650 times. Okay, let's move on to the next. See, if two positive integers a and b are written as a x cube y square and b x y cube, x, y are prime numbers, then HCF of a comma b. See, this type of problem we already discussed in the second one, maybe third or fourth, I hope. Yeah, here we discuss the same thing. Least power we should have to concentrate. Okay, let us see. HCF we want to find, and in both A and B, what are the multiples are there? X, X. HCF means common thing you should have to take. X, X, and Y is also there both, so we will take Y. And now we should look after the powers. HCF means least power we need to take. So X cube, X power X only means X power 1. So 3 1 1, and Y square and Y cube. The least is 2. So we'll take 2. So the answer is x into y square. X into y square. If you want to find LCM of this, how can you find? LCM means x, y. Whatever multiples are there, all we will take. And we will take the maximum power. Here x maximum is 3 and y maximum is 3. This is LCM and this is the HCF. This is our required answer. They asked for HCF. Okay. Coming to the next. Next is also similar model. I think, can you guess the answer? I will give 2-3 seconds time. By seeing in the snap of time, you can say that. They are asking about LCM. The P and Q is the multiples of A, B. Sorry, A and B, and A power is max. Since it is LCM, we should have to consider the maximum power. A cube and B square. So this is our answer. Option C. A cube B square is LCM. For suppose for the same, if you want to find HCF, what is HCF? The same thing we will take, and we will consider the minimum power or least power. So A power 1 and B power 1. AB is HCF. LCM, they asked for LCM, so our answer is A cube B square. I hope you understand this. I think you all are clear. Next, move on to the next question. Find the largest number which divides 245 and 1037, leaving the remainder 5 in each case. Okay. Here, the keyword is given in the question. Largest number. When they are asking about to find the largest number, we need to find HCF. And here some twist is there. What is the twist? Leaving remainder 5 in each case. So before finding the HCF, we should have to subtract 5 from the given number. See, in both cases, it is leaves remainder 5. So we'll subtract 5 from the both numbers. Then the resultant numbers is 240 and 1032. So the required largest number is HCF of 240 and 1032. Let us find 240. We will use here long division method. Or else continuous division method. It is 4 times 960. If you take, it is 72 is the remainder here. And now this 240 become dividend here. And this remainder become divisor. It is 3 times 216 and it is of 24 times. Again 72 become dividend here. 3 times 72 and the remainder is 0. At what divisor will get remainder 0? That will be the HCF. That will be the HCF. So here our HCF is 24. So the required number is 24. 24. Option A is the correct answer. Now move on to the next question. Question number 8. The largest number which divides 70 and 124, leaving remainder 5 and 8. See, here also the same like above question. the largest number. The keyword is largest number. So we need to find here HCF only. And in the above question, it leaves remainder 5 in both cases. In both numbers, it leaves same remainder. But here, in both numbers, it leaves different reminders. So to find we should have to subtract 5 from the first number and 8 from the next number. So the resultant numbers are, it is 65 and it is 117. So the required largest number is HCF of 65 and 117. See, we will use the common division method. See, 65 and 73 will come in 13 table. It is 5 times and it is 9 times. So 5 and 9 will not come in any other table. So the HCF will be 13. The HCF will be 13. To find LCM, we should have to multiply 13 into 5 into 9. To find HCF, we should have to consider the number which divides the both number. That's it. So here 13 is our answer. You can also solve using this common division method. You will get the same answer. Try by your own. If you have any doubt, raise your doubt in the comment section. Okay, let's move on to the next question. See, question number 9. A and B are two positive integers such that the least prime factor of A is 3 and the least prime factor of B is 5. Then the least prime factor of A plus B is, the least prime factor of A plus B is, okay. To do this, we will consider a small example. Let a number A be 6 and let the number B be 15. Here the prime factorization of A will be 2 into 3 and the least prime factor is, oh sorry, 1 second. And question number 9. A and B are two positive integers such that the least prime factor of A is 3 and least prime factor of B is 5. Okay. We will find this answer by considering two numbers. For suppose A has 15 and B has 25. So the prime factorization of A is 3 into 5. The least prime factor is 3 according to the question. Yes, A is 3. And B is 5 into 5. B prime factorization is 5 into 5. According to the question, least prime factorization of B is 5. Yes, fine. Now they are talking about the least prime factor of A plus B. What is the A plus B here? 15 plus 25. What is it? 15 plus 25? 15 plus 25, that is 40. What is the prime factorization of 40? 2 into, next, again 2 into, again 2 into 5. Yes. 2 to the power 4 to 8, 8 into 5, 40. The least prime factorization is 2. So the answer is 2. Do you understand? We will consider one more example or else. For suppose A is 21 and B is 35. We are considering another example which A is 21 and B is 35. The prime factorization of 21 is 3 into 7, whose least prime factor is 3. Yes. And it is 5 into 7, whose least prime factorization is 5. Yes, fine. Now we will find A plus B. 21 plus 35, that is 56. It is a multiple of 2. 2 into, for suppose 28. Again 2 into, 7. So the least prime factorization is 2. So here also we'll get 2 and here also we get 2. So answer is 2. Our answer is 2. I hope you understand. Okay. Let's see next question. What is the least number that is divisible by all natural numbers from 1 to 10? Both inclusive means we should have to include 1 and 10 also. Means the least number which is divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you have any guess? The least number which divisible by LCM of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is very difficult to find all LCM of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can remember this answer by directly. How to remember that? So it is directly we can remember. If you find LCM, you will get 2520. So the answer is 2520. You can remember it directly. What is the least number that is divisible by all natural numbers from 1 to 10? Is 2520. You can remember it directly. Okay, fine. We'll move on to the next question. The decimal extension of number 441 upon 2 square into 5 cube into 7 has, see, whenever you come across with these type of questions, we should check the denominator part. If the denominator is the product of only 2's and 5's, it is terminating. See, here 2's are there, 5's are there. Along with that, some extra number 7 is there. So you can fix it. It is a non-terminating. It is a non-terminating. And the question is it repeating or non-repeating? See, if it is a non-repeating decimal expansion, it is not an irrational number. It cannot be expressed in p by q form. If it is non-repeating terminating decimal, it cannot be expressed in p by q form. But the given question is in p by q form, so it is non-repeating non-terminating but repeating. This is our option. This is the correct answer. Again, I am repeating. Before, whenever they gave the question of the p by q form decimal expansion, we should have to check the denominator. If the denominator is the multiples of 2's and 5's, it is a terminating. There is no other choice. Directly you can guess. But here, including with 2 power m and 5 power n, some other multiples also there. So it is non-repeating. It is a definitely it is non-repeating, non-terminating. Sorry, definitely it is non-terminating. The thing is, we should have to decide whether it is a repeating or non-repeating. Repeating or non-repeating, we need to decide. See, if it was a non-repeating one, if it was a non-repeating one, if it was a non-repeating, non-terminating decimal, it is not a rational number. It is not a rational number. It cannot express in p by q form. Do you able to understand? It cannot express in p by q form, but the given decimal expansion is in p by q form. So we have only two options. One is terminating, another one is non-terminating, repeating. So it is not terminating. Why? Because we are having 7 extra here. It is not repeating. So this is also not our option. So we left with only non-terminating repeating. So this is option B is our answer. I hope you all are clear. Okay, let us see next question. If P is a prime number and P divides K square, then P divides K. Then P divides K. We have a theorem. If P is prime and P divides K square, then P also divides K, then P also divides K. Let us see an example. For example, if you take 2, okay, 2 divides 4 square, how much? 16. That means 2 divides 4. Am I right? Another example. 3 divides 15 square. How much 15 square? 225. It means 3 divides 15. 3 divides 225. It means 3 divides 15. Why? Because 225 is expressed as 15 square. So our answer is K. It is a textbook theorem. This theorem we will use to prove that root 2, root 3 are irrational numbers by using the contradiction. Okay, let's move on to the next question. If P and Q are two consecutive natural numbers, then HCF A comma B are C. The HCF of two consecutive natural numbers always be 1. Always the HCF of two consecutive natural numbers always be 1. It is always 1. For example, the HCF of 3 comma 4 is 1. The HCF of 5 comma 6 is 1. The HCF of 11 comma 12 is 1. The HCF of 15 comma 16 is 1. The HCF of 105 comma 106 is 1. The HCF of two consecutive natural numbers is always 1. So here in question there is a printing mistake. If P and Q are two consecutive natural numbers, HCF of not A and B, it is P and Q. HCF of P and Q is always 1. Okay, next question, number 14. Given that HCF is, I think we already done this question. Yeah. So again, once just we will recall it. We know that product of two numbers is equal to product of HCF and LCM. So HCF is 40 and LCM is 252 into K. Product of two numbers is 2520 into 6600. So K will be 2520 into 6600 upon 40 into 252. In 252, 2520 10 times. 10 table 40 4 times. So I left with 6600 upon 4. It is 1650. 1650. Option A. Okay, let's move on to the next question. The smallest number which when divisible by 17, 23 and 29 leaves remainder 11. See here we can observe that the keyword is the smallest number. So whenever we find the smallest number, it should be the LCM. And here they given one twist, leaves remainder 11. See, while we are finding the HCF in the similar case where we are getting reminders, first we subtract that reminder and then we find HCF. But in LCM, it is a reverse. First, you should find LCM and then subtract that reminder from that LCM. So the LCM, we will find the LCM by using the long division method. 17, 23, 29. Since 17, 23, 29 are prime numbers, their LCM will be the product, their product, the LCM. So the LCM will be here 17 into 23 into 29. Why? Because these all three are prime numbers. How much it is? 17 into 23 it is 391 and into 29 we need to do 391 into 29. 981 8 carry 27 plus 8 it is 35. 2 18 1 carry 6 plus 1 7 9 3 again 3 1 carry it is 11. So 11339. So the required number is required smallest number leaves remainder 11. 11,339 minus, we should have to add. Oh, then it will be 11350. So option B is our answer. See, while coming to the smallest number leaves remainder, we should have to add that remainder to the LCM. We should have to add that remainder to the LCM. While coming to the HCF, we should have to subtract it. We should have to subtract it. But the subtraction should be at the beginning. See, once we will recall that. See, while finding the largest number leaving remainder, first we will subtract the remainder from the given numbers and then we find HCF. But in this case, we will find LCM of the given numbers, and from that LCM to that LCM we will add the remainder. Do you understand the difference? Don't get confused. Okay, let's move on to the next question. Let the age of Anjali and Beena be A and B such that A is given P cube into Q power 4 and B is given P square into Q power 3. And their HCF is given P power M into Q power M. LCM is given P power R into Q power S. Then we need to find M plus N into R plus S. Okay, first we will find HCF and LCM. HCF, from this we will find HCF of AB. P is there in both and Q is also there in both. And for HCF we will take the least power. So P square Q cube. This is nothing but given what? P power M into Q power N. So by comparing the bases and their exponents, M is 2, N is 3. P square P power M. So M bases P's are equal. So their exponents also equal. M is equal to 2. If bases equal, powers also equal. So 3 is equal to N. Similarly, now we will find LCM. LCM means maximum power. P cube Q power 4. This is nothing but what? P power R Q power S. So compare the exponents. So R is equal to 3 and S is equal to 4. And they are asking us to find M plus N into R plus S. M is 2 plus 3, 3 plus 4, 5 into 7, that is 35. So our answer is 35. Option C is the correct answer. Okay. Let's move on to the next question. See here, assertion and reasoning type questions. Let us see the first one. Assertion, 17th question. If the product of two numbers is 5,780 and their HCF is 17, then their LCM is 340. Okay, let us check first statement is 2 and the second. Let us see the second one. Reason. HCF is always the factor of LCM. Okay, we will cross check the both. See, product of two numbers is given. Product of two numbers. We know that product of two numbers is equal to LCM into HCF. Am I right? Yeah. Product of two numbers is equal to LCM into HCF. Product of two numbers is 5780. LCM, we need to find. First, we will take LCM into 17. Let us divide with 17. So it is 17 table. It is 17 threes, 51. 68, it is 4 times and 0. Yes, 340. So it is true. First statement is true. First statement is true. What about the next? HCF is always the factor of LCM. See, observe the HCF here 17 and LCM is 340. Yes, 340 can be written as 17 into 20. So HCF is a factor of LCM. Yes, this is also true. Now we should have to check whether this reason is suitable for the given assertion or not. See, what is the reason we applied? What is the concept we applied here? Product of two numbers is equal to LCM into HCF. But the reason is HCF is always factor of LCM. This can't help us to find this LCM here. This can't help us to find the LCM here. So, here both assertion and reasoning are true. But reason is not correct explanation of A. Reason is not correct explanation of A. Option B is our correct answer. Now come to the next reason. 6 power n can end with digit 0 for any natural number n. Reason. Any positive integer ending with the digit 0 or 5 is divisible by 5. Yes, here see. We need to check whether 6 power n can end with 0 or not. Here they given, if any number ending with 0 or 5, it should consider, it consists of, its prime factorization consists of 5. Let us see, prime factorization of 6 is 2 into 3. So for suppose 6 square is 2 into 2 into 3 into 3. So for suppose 6 cube is 2 into 2 into 2 into 2, 3 into 3 into 3 into 3. So 5 is not coming anywhere. So 6 power n can never end with 0. 6 power n can end with 0 the given. So it is false. It is completely absolutely false. Why? Because the reason is given. Its prime factorization should consist of 5. Since it is not consist of 5, it is not end with 0. But it is given can end with 0. It is false. So A is false, R is true. A is false, R is true. Okay, next. I hope you all understand this. I hope the given MCQs for class 10 maths real numbers with answers will help you a lot for the coming board examinations. If you have any queries regarding the CBSE first chapter, class 10 first chapter real numbers in multiple choice questions or in any other things, please drop a comment below in the comment box and we'll get you back at the as early as possible. Thank you. Thank you for watching. If you like the video, please click the like button, subscribe my channel and share to your friends and click the bell icon and select all. Thank you. Thank you, dear. Bye.